we plan to cover today is we'll discuss the what. So just to level set as to what observability means, and it's not just some of the basic principles and elements that people always look at, even as developers, right? Then why is it a first class citizen and not an afterthought? I don't know how many of you have print log statements in your code, but that's a common problem, right? It's a huge problem. How to build an observable system? Okay, so we'll talk about that. Who are the key stakeholders? Like dev and ops are not the only stakeholders. There are many other people that's involved, and your application code and metrics are not the only source of data. There are many more things that you have to think about. And finally, some practices based on what we have done with our experience with our customers, what we have seen, what works, what doesn't work. We'll probably talk about that as well. And finally, any questions that y'all might have with us, we can take that. Yeah. So before we go ahead, how many people are devs here? Oh, awesome. How many ops, SRE? Cool. So let me ask for the first question. What is your definition of observability? There is no right and wrong answer, folks. Yeah, even I don't know the right answer because it keeps on changing. What's your definition of observability? All are right definitions, and all have, because it's, I'm not saying any of these definitions are wrong, right? We have used observability in different pockets, and it's like looking at an elephant and we are holding different parts of the elephant and we think that's observability. Okay, so what we're going to talk about is, Pooja is going to now start on what we think is observability, and we'll probably try to level set on what is an expectation of observability, and then we'll take it from there. Yeah.
So it's again based on our experience, again multiple hurdles internally to actually align on what is observability, how do you sort of implement that in the context of multiple clients. Each clients have different asks, each client's maturity that we have is different. So we typically start from different, our ground zero is different in every client. So bear with us that this is based on our learning. Please ask your questions, your thoughts. Feel free to keep them coming.
Feel free to challenge us also.
Yeah.
We'll point you to some YouTube videos. But anyway.
Cool. So before we start with what we think is observability, some of the things that we've commonly heard others speak about, and slightly differing from our opinion. I think the first one is having monitoring in place means that you have observability. The second thing we have heard is having just APM in place is observability. And the third set of people go a little like a step further. They say that if we have metrics, logs, and traces in place, we have observability, right? Like metrics, traces, and logs are considered as three pillars of observability. I think that's one of the most common way to think about observability these days. But the reason why we feel that's not entirely accurate is because of these three reasons, right? Like metrics, logs, and traces by themselves are just telemetry. They are the data that you need to be able to collect so that you can make your systems observable. And second thing is, if you have these three different siloed pillars, each of them have their own tooling, right? You would collect metrics in one tool, you collect your logs in another, and tracing has another tool. But the problem that we see that arises out of that is you have three different tools that you need to go and figure out, debug to be able to come up with one source, right? And that leads to the third problem, where who is the person who's debugging it? That is the entire approach to debugging depends on that one person. So you might have often heard people saying, hey, bring person XYZ, right? He or she will be able to debug this faster. That's not how you should be thinking about observability, right? Everybody and anybody should be able to come and figure out what the problem is. So this is what we feel might be a little bit of a negative impact of thinking about these as three different siloed pillars, right? So having said that, what is observability? If you Google, this is a definition that you get. It's a measure of how well the internal states of a system can be inferred from external output. So what that actually means is you should be able to look at your system as a black box, right? People might not know what's happening within your system, but from the output that your system is generating, you should be able to figure out that this is the problem, this is where the source of the error is, and that's what you mean by having observability in your system. Another way to look at it is, if If there are any issues that happen in your system, how easily are you able to debug it without having to ship in new code or configuration? That's how well your system is observable. So I'll talk a bit about how observability has evolved, right? Some of us said that having monitoring in place will ensure that you have observability. It is, yes, but the way to think about it is traditional monitoring has usually told us that something has gone wrong. It doesn't always tell you what is wrong and where things have gone wrong, right? Versus observability, which will tell you proactively as to what has gone wrong. So what I mean by that is, like I was saying, when you have traditional monitoring in place, it is very much person dependent, right? Like who is the person who has implemented that particular feature, or who is the person who's seen that particular error trend in the past. If that person comes and debugs, then you'll find the solution easily. Versus somebody new to the system who comes in, it'll be more difficult for them to debug the issue. That's the problem with traditional monitoring. Whereas observability is more objective, it is extremely data driven, which means that if you have people who can ask the right questions to your tools, right questions to your logs and metrics, then they'll be able to debug the entire issue. The second problem that we see with this kind of thinking is traditional monitoring is pretty reactive, right? Which means that you'll be able to uncover known unknowns. So if there are problems that you anticipate in hindsight that this is going to happen, you'll put in the logs for it, you'll put in the metrics for it to figure out that this is what has gone wrong, which means it's reactive. So if any new problem happens, you would not know how do I debug this issue, right? You wouldn't have the data to do it. Which is why we say in observability, you would capture all the data upfront that is required to be able to debug an issue. And that's why observability is very proactive. I think one of you said that it helps you proactively debug issues, and that's, I think we feel like that's a pretty good definition of what observability is.
I don't know how many people write very nice logs, right? Logs is always an afterthought. In here, out there, if in it, sometimes the sprint is there, sometimes debug is forgotten, there's a lot of code writing and you're spending a lot of money. So
in fact, I've seen stories which says add logs to your code base, right? And that's like a never ending story. People come and ask you, why is the story not getting done? Like you can't say there is a definition of done for add logs to your code base, right?
And that's a question to all the devs, right? Why is that? Because technically observability is for us. We always complain to business saying that, hey, business doesn't give me time for this and all that. This technically is for us so that we don't spend time looking for problems, but we also don't do jobs that make life easy, right? And it's for devs and ops and SRE, right? I'm just trying to bring all of them together. So let's define what's the black box. Okay, so Pooja's first slide was a simple black box of 3 dabbas and life was cool. Today, modern distributed systems have a lot of things: load balancers, caches, databases, different types of databases, different microservices. Okay, so if building a distributed application is hard, observability for that is harder. Okay, that's what we have learned. And because of the fact that it's so many things happening, so many protocols, it's a mishmash of things. And the thing is consistency, right? Like how many people, I think most of you all work with microservices, you have teams building microservices. How do you ensure that team A's logging standards are similar to team B's logging standards? And they are part of the same, let's say if you're looking at an order processing flow, right? All the teams are part of the flow. But if they are not writing things that can talk to each other, then you have a problem. Okay, then you are struggling, right? That is where Pooja was saying that you have to call people in the midnight saying, hey, somewhere something is wrong. I don't know if it's the invoice service or the order service or the thing. We have to figure this out, right? So, observability, if the whole idea behind it is if I can figure that out, anybody in the team, right? It's not like who is the order expert, who is the invoice expert, who is the billing expert, who is this, let's catch them, right? If anybody can figure that out just by querying, I think we have an observable system, because I don't know what will fail. How many of you face certificate error issues, 503? I don't know, rotation error issues, right? These are standard stuff. And you are struggling the entire many hours just to trying to figure out what the hell happened. Okay, it's a lot of, I think we all have burnt our fingers on this, but that happens, right? So I just want to take a view of a day in the life of a DevOps team, okay? And this is a team which has logs, metrics, and how we do it today, right? So we have an app Please ignore if this is not really domain driven, please. But it's you have order service, payment service, invoice loyalty, the typical stuff, right? So let's say something goes wrong. Now, if the entire service goes wrong, it's still easier to find. What if an instance goes wrong? How do you figure that out? Okay, so you suddenly have certain percentage of your customers complaining that my app doesn't work, right? So now what's happening at the other end of the spectrum? What's happening with what are we doing? So suddenly we have the monitoring team looking for a Prometheus dashboard or Grafana dashboard and saying which one there is a 503 spike. Okay, then it's okay, something is going up, then I need to figure out what else is going up or going down. So we're looking at other traces and matrices to see if we are figuring that out. So if we go click this, and then we're trying to correlate, and we're trying to form a hypothesis now. Okay, 503 errors are coming. Now where it is coming from? Okay, so we're forming a hypothesis. Now I need to go and find my logs. If I have hundreds of nodes running multiple services in a Kubernetes or something like that, I don't even know where is my service running and which instance is failing. So you're trying to do some again. That's my gripe with logs, right? We write text in logs. It's hard to grep text. So all of you have to be grep ninjas to figure out where is the problem, right? Because there is no attributes you're searching for. You're searching for string matching. Okay. And then finally you're trying to figure that out. You filter it saying that, these are the two logs I need to look at. And then when I open it, I find, okay, maybe a certificate rotation error has happened or something like that. I need to go fix it. It could be, and I don't know if people have worked in service mesh, sometimes propagations don't happen. And you'll have these strange issues that you have to figure it out as to what happened. You will be just in one node and you're getting that, right? So you have these kind of issues. Everything stops working, easy to debug. One small percentage doesn't work, very hard to debug. So what we are trying to say is that we need some sort of an index to tie the logs, the events, the metrics, all of these together. And that is what tracing is technically. Okay, so a lot of people use tracing. And we use tracing as a separate, like you will have a Jaeger or Zipkin that is setting up tracing. You'll have Prometheus running metrics, you'll have logs, and there's no correlation. Okay, so you're not able to figure out that if something went wrong, which log should I go find it? That chain is missing. And tracing provides you that index to figure that out. Because the idea is that you need to track it from a business event, not a 503 error. You track a business event and your tracing gives that, okay, to submit order, what are all the services that change hands to solve it, right? And you're you're finding the trace to get you that, right? And in our way, tracing is that glue that stitches log and metrics together. And if you don't have the glue, it becomes very hard to figure that out. Okay, so although we have a definition of pillars, logs, metrics, traces, but they somehow have evolved as independent pillars. Some of these things, if you read about OpenTelemetry, they're trying to solve this problem. They're trying to mix the two together. So again, we are not doing a very tool-specific conversation because there are enough tools in the market. I don't want to be selling anything here. But the idea is that they're trying to bring this together, and that is the problem that has to be solved to get that answer, right? Now, once we are done with the why do we need this? Because you are trying to save time to solve this. Let's see, how do we go about building it, right? And we just get a double click on that, and Pooja will take you to the next set of slides.
So what we have seen is having a structured event. I'll tell what that is the building block for having an observable system. So to take an example, let's say that there's a user who places an order and that passes through your API gateway, order service and payment service, right? So if you consider that as a flow, you would start something called as an event, wherein you would put in very basic information, right? Like potentially a request ID, you'd possibly pass, the request parameter saying, this is the user ID, this is the query that we did, and these are the order items, things like that, right? And then when your request passes into the order service, the same event gets propagated there and you add more information into that event. So you basically enrich that event to say, hey, this is the order info that this request came into your service with. And as that flows into the payment service, you'll add more information, basically payment information. But if you notice, it's the same request that's getting traced through, right? So that's what Navin was talking about, something like a correlation ID or a request ID or a trace ID, which actually helps you connect the entire event across different services, different systems that you pass through, right? So that's what we call as a structured event. Basically, it's a rich context of your entire request lifecycle. it's arbitrarily wide, which means it's useful to pump in as much as data that you think will be needed for debugging at a later point, like which instance, which host did it come through, what was the exact request parameter, the timestamp, the ID that came, the user ID and things like that, right? And it's essentially just a map of key value pairs, if you look at it at the end of the day, and that's organized for easy search. Even though you might have data, it's important that you should be able to search for it easily, right? Otherwise, there's no point in collecting random data and keeping.
I want to talk about the arbitrarily wide event, right? I think one of the reasons I want to talk about it, and wide versus deep. So wide because you're trying to put as many things in a single log line, and we'll talk about what are the patterns around logging as well, but so that you can get that information together rather than having different small pieces put in multiple lines. Okay, so that is what we're trying to do, and the thought process should be that we tend to overlog, either overlog or underlog. There is no right log. So overlogging, so there should be logging for happy flows, we should be logging for unhappy flows. Okay, that's your info. Your debug could be a little bit more thing, but your info log cannot be so many things that you're dumping into the log file. And anybody who has spent a lot of money on any of these logging providers who charge you by the amount of logs that you push it, you will know. And then it becomes a separate exercise to say now reduce logs, right? So that becomes a problem. So, and we'll talk about some patterns as to how we can solve that problem, but we'll come to that. Yes, not really. I'll be very honest, right? So there is no open bullet or a silver bullet, a right of this, right? What we're trying to say, these are some patterns that we need to try to do to make your life easier. Okay, and because the other thing, bear in mind, right? Some of these open telemetry is very dev centric or DevOps centric, right? But if you start going wider and you go into like engineering manager is interested in about life cycle metrics, pipeline, CFR, change failure rate or deployment frequency. So observability we'll talk about that as well. But anyways, it could be many things. And so open telemetry doesn't answer all that question. At least it makes certain life easy. And since there are a lot of dev and ops folks, I thought, okay, let's make their life easy today. So you can do telemetry the way you want it. You won't get observability. Getting my slight difference, right? See, the whole idea is that if you want to figure out what is going wrong, you need to connect these three together. Today, traditionally, we are not connecting. At least, I'm assuming most of us, we are not connecting. Okay, so what we are saying is we should connect it.
Yeah, and that's why I said that the 3-pillar model is a slight step ahead of the traditional monitoring that we're thinking about, right? Like it does definitely help you debug. It's just the time that gets invested in figuring out. It's very person dependent also, right? That you need to know where to go look for what. And it's not very objective, which is why we recommend to have all of that unified view to be able to debug the problem. Cool. So I just want to double click a bit on the traces bit that Navin was saying. So I think this is a very simple example, right? Like we all know that requests to each of our services can come out of order. It need not come in the way it arrived from the user, right? And how do you ensure that the same, I've taken a log example here, but how do you ensure that the logs are correlated across different services? You might see payment failed in your payment logs, right? But how do you know that payment XYZ failed for order number XYZ, right? So that is why we need to be able to correlate and connect a same request that goes through multiple different services, right? Here I've taken request ID as one of the ways to do that. But potentially, if you think about traces, so we talk about one request being one trace, and each of it has different chunks, which could be multiple services, it could be different databases, it could be different external systems also. Each of those chunks are what we call as a span, and with an interconnection of trace ID with parent-child dependencies on span is how you can trace an entire request. So what I mean by that is, if you look at the overall request, right, that's post order, that has multiple flows. So you'll first get an inventory to figure out if the stock is available, right? So let's say a request goes into the inventory service. There's also a call that goes into the payment service once your inventory is available, and that sort of potentially goes and calls your address service to get your billing address, shipping address, whatnot, right? But how do you sort of connect this entire thing back to a single order request. Here we've given a trace ID, right? The one blue, that's what connects the entire request. And the source of each of these services are different. Like the payment service source right now is the order, the flash order, right? And the address service right now is coming in through the payment service. So there's a parent-child dependency between your payment and address, but potentially your address service could get directly called from the website itself, right? So how do you sort of ensure that these services are connected? That's where our parent span ID also comes into play. So how this actually helps us is if you have a view like this, right? So on the left side is just a structured event example, right? So you potentially pump in all of the data that you might need at some point of time. But if you look at the right side, that gives you a drill down view. So what happened in this particular trace? If you want to go inside that trace and say, hey, what happened in this particular span? And what happened in the child caller of that? So that drill down view is what is the second half, right? And that's really important to be able to narrow down on what exactly happened with this request. And that view will come, like Navin was saying, if you have your traces deep and your events are sort of wide to collect as much data as possible.
Yeah, so one of the things I would really highly recommend is logs should be as structured as possible. So I can't reiterate this enough because string matching is a pain. We all know that. So please, I think whatever we have seen, because all the nirvana we are talking about unknowns can only happen if I query on those attributes. If my attributes are all string matches and all that, it becomes a pain to actually do that. So structured logging, and there are libraries that help you do that. You don't need to necessarily create JSONs and all that around that, but you can create key value pairs and it can help you with that. And you can use that, and then if you put it into any kind of Loki or an Elastic or whatever machines you're using, right? You can just query it, and you can do a lot of those comparisons, and you can figure that out fairly quickly. So I have worked with customers who have a lot of logs which are just strings, and I've spent a lot of midnights trying to figure out where to find the issues and all the greps and all. So I'm just trying to say, if something that you start from scratch, of course, legacy can't do much, but if something you're starting from scratch, please think about this, because this will help a lot going forward when you start scaling your system. Okay, so who are the key stakeholders? I think we had one person asking about that, right? So is OpenTelemetry enough, and who are the key stakeholders we are trying to do, right? So our point is observability is not just for dev and ops or SRE, right? There are many more personas that are involved around this, right? So, and that is very important when and we are talking about that in the next slide, but what metrics are important? Because if you don't understand who's going to consume the metrics, you'll just put stuff. And again, it's back to junk in, junk out, right? You're just putting something for the sake of doing it, because there is a storyline saying add logging or add metrics, right? So what we are saying is, if you look at dev team, we are more interested in fixing bugs, improving performance. So you're looking at things like latency, garbage collecting, how many times the garbage collector was called, the success rate, error, etc. Right? You come to the SRE team and all that, you're looking at again TPS, error rate, MTTR, a very important metric, mean time to restore, mean time between failures, and resource utilization. So those are the things we're worried about. If you look at business teams don't care about what's happening at a application level. Right? They are worried about user experience, right? How much percentage of the user dropped out, product search experience, right? Or you're talking about revenue related metrics. Okay, so they're talking more interested in that. And if you look at head of engineering, now they are looking at a slightly above level. They are looking at, okay, DORA metrics. When you say DORA metrics, you're looking at the 4 key metrics, if I'm not sure if you are aware of it, which are the DevOps metrics. So they are aggregate metrics to see what is the state of your DevOps practices and all that. So you have things like lead time to change, you have change failure rate, deployment frequency, and mean time to restore. Right? Those are the 4 things. If you see if they are all green, then that means things are going well. So they are looking at a higher level across all the engineering teams, how things are going. They're looking at code quality, CSAT. So the metrics changes, and what we select as part of your observability goals depends upon that. Now bear in mind, not everything is answered by OpenTelemetry. Okay. Now I can figure out, and there is a lot of conversation around, should I move some of these metrics left? Like today, if there is a production downtime, How many times would you know how much revenue was impacted because of your 2 hours of revenue downtime? You can easily query that using your own systems because you have it. You just query your order thing and just see the sum the value. You'll figure out how much typically is a 1 hour that happens, and if you had a 2 hour downtime, how much it is, right? There are benefits to that. Bear in mind, business will use a Google Analytics. Business will use data platforms and other things also to look at that. But some of these things shifting to the left also helps to figure out how much is the impact that you're driving to your business, because I can see those metrics on the dev side. I'm left shifting it, right? So that also helps in some of these cases because I just don't know what's the impact I'm driving. I just look at metrics. Dev looks at only metrics and looks at our metrics. I don't care about how much revenue, right? So this is just a subset. We are looking at QA, product managers, data engineers. If you look at data platform, the observability metrics are very different. Or additional metrics are there, right? You're talking data quality. You're talking those kind of you're talking about those attributes. Right? And finally, you're talking about the application performance metrics and all that. Right? So you're talking about those kind of things that you have to think about what metrics are important for you, because that drives what observability you're trying to drive at. Okay, so and once you do that, then that goes to the next set of things that we're going to talk about. If you can just go to the next slide. How do we define what are the sensible defaults? Okay, so I need to understand my observability stakeholders. Okay, and to do that, one of the things we're trying to say is try to make observability as a first class citizen, that is left shifted, right? So it is not something where you say add a log, you define it as your acceptance criteria. So if you have a team which has your devs, QAs, folks all sitting together, you can have your acceptance criteria saying that I just put some examples. This is something I cooked up, saying that 500 millisecond is my latency expected. Anything more than that, I have a problem. Okay. If there is I want to define threshold that 1% if there is error, then it is probably minor. 5% is major. 10% error rate is maybe critical. So the reason of putting this is that makes devs intentional about observability, because your QA is not going to clear it if these measures are not being measured. Okay, and that's one of the reason we are saying that it should not be an afterthought that Navin, as part of your story, put some few log files, but we are also saying it has to left shift that. Okay.
And I think what it also helps is the fact that the person who's implementing that story has the maximum context to be able to put in the right logs for that, right? Like it's not somebody else who's looking at my code and figuring out this is the right log to put in place, but it's the person who's actually implementing it, which makes a lot of difference in the kind of logs, the description that you go in, the kind of metrics that you collect, and that's what gets achieved if you start thinking about it upfront.
And one of the most important thing I want to call out, some of this is like build observability from start, all this is common, right? One very important thing is you're never going to get observability right first time. Right? It's always a evolutionary thing. I think Thoughtful still believes a lot about things has to be evolutionary. There is no perfect architecture day one, and there is no perfect observability day one. You will learn, you will see things are not working, you will improve. So that feedback loop has to happen. So the continuous improvement feedback loop is something that happens that needs to be thought through. Alerts. How many have got set up alerts and there is a lot of alert fatigue, right? So many alerts, right? And we are only writing alerts for ourselves only. Okay, so my hypothesis is that we need to probably do a pyramid of alerts as to what are important alerts. And again, this goes back to your ODD, because in a ODD you will be putting object-driven development. You will say that what is a major alert, what is a minor alert, and there might be some which are just info alerts, like auto scaling has happened. I don't need to be getting notified. I just go to a Slack channel somewhere and let it be there, right? But if something is dipping, then I have a problem, right? So actionable alerts is something that is very important, and we've been part of projects where there are alerts flying left, right, and center, and figuring out what alerts to look at itself becomes a problem. But cleaning up the alert is a very, very important thing, and that decision also comes back to the story. You go left and figure out what are the alerts that matters to me.
Yeah, and I think this is one of the other things that at least I learned the hard way, right? Like we just ignored a lot of these alerts because they were just some validation errors, which actually never needed an alert to be thrown, right? But we actually lost like a very important error that was happening because we said, okay, this is just an address validation error, right? And that proved really costly for us and the business. So which is why we are actually very, very conscious about the type of alerts that you need to come in. If it's really critical, that's the only time that you need, like 24/7 kind of a support, right? And that's when those are the alerts that actually matter.
Yeah, and you don't need to keep an eye on it. You can connect to a PagerDuty or Opsgenie or whatever. Any of these tools that can just or connect to an SMS or whatever, just to get that okay, there's something that you need to be bothered about, right? So those are things. So the idea is that the system tells you something is wrong. Rather, you go and do a refresh or keep an eye on what is happening on your monitoring dashboards. And that is what we're trying to do. And again, of course, even alerting, there is a lot of arguments around, do I use Grafana alerting versus Prometheus alerting? I don't want to get into that. But the moral of the story is having clear alerts are important. Your triaging of alerts are important. And that is something that again happens if you take that as part of a story and you define saying why these errors are important for me, why these alerts are important for me. And once you do that, automatically makes sense because you're talking as a team, right? Why this is important for me. Observability as a code. So yeah, sorry, a lot of jargons around ODD and observability as code. But one of the things we are talking about is that your observability platform has to be repeatable and automatable, right? So that basically means that you don't want to be setting your platforms again and again as you go across different environments. So of course, you can use the standard stuff like Terraform to build your observability infrastructure, and you nowadays you can also get dashboards. You can build a Grafana dashboard through JSON. So the idea of putting that is you can put that in your Git, commit it, you can do version control it, and you can have it in a pipeline so that it can deploy across various environments. So you are not literally going and setting up dashboards. You can do that through a pipeline. Okay. Again, I don't know if anybody has done with Grafana JSON. They are a pain to work with. So there are templating tools like JSONet that can be used to build it. But again, Grafana is an example here, folks. Other tools are also claiming that they have observability as code. Okay.
Yeah, and the other thing I think it helps is the standardizing across the different teams, right? Like you might have a large enterprise with multiple different teams, multiple product teams. How do you sort of ensure that there is some standardized way of putting in observability? I think some of these templates will really help there.
Yeah. And finally, alerts. Yeah, alerts can also be as code. I mean, I'm just giving a few examples. There are many as codes that you can look for. But the idea is that you can do almost all of it automated via pipelines and without doing manual intervention, right? So all these things exist. You can think about putting that in your pipeline as well. And it could be part of your infra stories and all that you're taking. Sidecars. So not everything is instrumentable. Okay, we all work with a lot of legacy code and with very bad logging, hardly any metrics. So it becomes a problem that okay, all these statements about tracing and all that sounds very awesome, but my infrastructure, my order processing or something goes into a product, and I don't know what is happening, right? So how do I collect metrics around that? So sidecars are a way in which we have used it. Of course, there are challenges. Some of these products don't propagate trace headers and all that, so it's not a perfect solution. But in many cases, it does do a decent job. So anybody who's done service mesh, you have seen sidecars. You put that as a proxy in front of each application. So every communication that goes inside the application and outside the application goes to the sidecar. So technically, a sidecar becomes like a point where you can tap and get all the metrics out. You can get the logs out, whatever you want, right? So sidecar is a very easy way of adding thing in, especially in legacy code, because you can't do tracing tomorrow. Let's say a lot of old code, you can't do tracing tomorrow, right? The easiest way that put a sidecar in front of it, and you should be able to get some things out of it, right? So that's one way of doing it. There are multiple patterns. You can use your standard service mesh envoy kind of sidecars. By the way, the service mesh itself has gone beyond Kubernetes now. It has gone, you can also mesh it across VMs, like Istio supports it, console supports it. So many of the service mesh do support it. So it doesn't mean that it can only be done within a Kubernetes kind of environment. And the other thing is, if you don't like sidecars too much, then there are new technologies like eBPF that is coming, extended Berkeley packet filter, I think, which actually connects to your kernel and extracts traces out. So there are things like Cilium and all which work on that, and they run per node. So you don't run per workload, but you run per node, and you can collect that. So that's one more way of looking at it.
For integration to external systems, right? Many of the time, when things go wrong, if we were to interface with external teams as such, they would potentially just pass off the bug, right? Like they say, this is not a problem with us, right? So I've faced that problems multiple times, which is where this has helped, where you put in sidecars to sort of ensure that you know what is exactly going wrong, and you can show the data that hey, this is what has gone wrong with your system, right? So that way, it also helps you pinpoint your external dependencies a lot.
Yeah, but after manually configuring sidecars are not recommended. Pushing configuration across all the pods will be a pain, but yeah, okay. The most important part, right? Now all this is awesome. How do I ensure that my developers are not cheating on and putting stuff whatever they feel like, right? How do I govern that? Like, see, we all know. I'm sure we all read a lot of Medium articles, go to a lot of YouTube videos and all that. We know some of these practices are there, but if you open production log, it is filled with stuff. You look at metrics, we are just putting stuff in it, right? How do I govern it, right? So we may do observability driven development, we may put in the process, but how do I ensure that 6 months down the line, the optimum versus what it is there is a huge gap. Okay, so that is where we talk about governance, and governance is not just the quality of the log metrics and all that, but it also talks about you're not logging the wrong things, right? PII data, you're looking at your secrets. I don't know, many times you have seen secrets in the log file, API keys getting printed out, or database password being printed out, right? So how do you do that? Then that is where the governance place is. So governance is two parts. You have your manual governance, which is as part of your QA, checking your acceptance criteria and checking, okay, as part of my testing, are they logging the right things and are they not logging things that they should be doing? Is it structured enough or is it just text again, right? So those are the QA part of it. You can do also automated stuff where you can use libraries that can actually do search around it and figure out if there are any things like, for example, there are things which are redaction libraries are there that will redact any passwords and all that are there. We have put in some of the customers, we actually put custom logic. Like if you look at OpenTelemetry, and again an example, there's something of processors, so you can write your own code inside that, and you can check, okay, what is going in, you can review it and see that are there things that are going outside the practice and highlight it. You have an option to cut it, or you have an option to highlight it and inform people so that somebody can look at it, right? So that's one thing we are talking about. You can write custom rules on static code analysis tools so that you can also do that, again, left shift. So yeah, there are many ways of doing that, and auditing on your central log server, right? You can just see what log is going in. So we think governance is very important, because typically over a period of time, your logs and your events and your metrics do degrade, because people see, there is always the pressure between functionality and XFR. Cross-functional requirements. There's always the pressure is there. Your business will be hammering down on you saying that I want so many functionality, and so people try to take shortcuts. So how do you control it? You need to put in a strong governance process around it. Again, manual and automated. I think we have done automated and it has worked fairly well. We generally don't do a lot of manual code reviews and all that. Automation works fairly decent thing. That's together.
So, summary of what we spoke about, right? One is observability is a lot more than just having logs, metrics, and principles in place. You'll have to have a way to get a unified view and look through all of them. Think about it as one of the most important cross-functional requirements. So, when you're gathering requirements from your business, try and bake this in as your acceptance criteria, right? Thirdly, feedback loops. Navin stressed upon it. You don't get it right the first time at all, most often than not. So ensure that you keep an eye on this observability as an ongoing activity, not that, hey, I've implemented observability, I'm done, but it's an ongoing activity, right? You need to keep doing this as importantly as your development life cycle.
Thank you.